Hello everybody, today we'll be doing next grader, element number 2, given a circular integer array, nums. The next element of nums length minus 1, is nums 0. So basically, what this means is that we have a circular array, 1, 2, 1, and we have to circle back. This 1 will actually circle back, and this would be basically what's greater than this 1. Of course, this one's greater than that as well. So earlier we did a problem called next greater element number 1. And if you haven't seen that, please go to that video and check that one out. Otherwise, it'll be very difficult to understand what we're doing here in next greater element number 2. But essentially, what we're going to do is something very similar. We're going to create a monotonically decreasing stack. So to do this problem. Okay, so first of all, let's get to our understanding part. So what we want to know is that the inputs and outputs, what we're trying to get. And as you can see here, we're trying to find the next larger item. In this case, 1 was found by 2, and we cannot find any larger number, so then we return -1. Also, here we go. Let's check out our second example, and let's make some edge cases in a little bit. So let's check this one out. In this problem, we are given a 1 points to 2. Yeah, it makes sense. 2 points to 3. 3 points to 4. Perfect. 4 has nothing, and 3 points all the way back around the second time to find a 4. And that means that 4 is the answer for this problem, this particular item. Okay, very good. So essentially, if our time constraint is O of n squared, then it'll be pretty easy to do, but it would be much harder to do if we were to do it in O of n time. Because, yeah, how are we supposed to find the next larger number if we don't search everywhere else in the array, right? Sorry about that. I just skipped over the edge case. So edge case, right? Edge case, let's think about it. Input, maybe like 1 item, and that's always going to be -1. That's the minimum, and the maximum is whatever it's going to be. It's going to be 10 to the 4 power. So this is going to return just -1 because it can't find anything. So basically, we're going to try for the O of n method. And the method involves monotonically. It involves O of n space as well. And it involves a time space. Involves a monotonically decreasing stack. So how does this work? Well, the plan is to look at create a stack, input items into the stack. If there is a greater item compared to the stack, that means we have found the item and we need to insert it into our answers. So our answer for 1 when we see 2 is that, well, that means this item is going to be, at this particular index, is going to be 2. So at 0 index, we have a 2. Pretty easy. Now, this item disappears, and we're putting 2 in. The 2 goes in, and we're looking for, and then there's a 1 comes in, and there's nothing bigger than the 1. And now the 1 goes in one more time because we're doing a full loop. Okay? So the 1 goes in one more time. And lastly, we have the 2. So this is our second loop through everything. So with this 2, we can see that this particular number is a 1. And that means that we can set, this is, of course, 0 indexed. And this is, our index is here, is going to be 2. Of course, this is 1. So instead of storing the value, we can store a number. We can also store the index and the value if we want. But let's just talk about the index. and that way we can place them in the correct place. So we see the 2, and we put this 2 back into the 0 index. This is going to be still -1 in the 1 index, and then we see the 1 in the 2 index, and that means we are going to set the 2 index to be 2 because we found the bigger item, and that's where we're going to place this item. And once we're done with that, we are able to see that there are still items in the stack, but that doesn't matter because we're done with a loop and we have our answer already. So again, it is a monotonically decreasing stack where we insert smaller and smaller items until we see a bigger item, and using that bigger item, we remove items from the stack one at a time until the item is no longer bigger than any item, and we insert it into the stack. And with that, we are able to say for sure that all those items that are bigger than that this current number is bigger than all those previous items in that index. So that's the plan, is to create a stack, create answers array, and what else do we need to create? I think that's good. That's good. We're gonna do 2 loops because of the circular array. So because we have the items inside the stack that we can manage in our second round, and what we're gonna do is insert item into stack, and while let's say while stack and the stack top is lesser than num, then remove stack from stack, pop from stack, and set number to be max val at the stack index, at the given index from the stack. What we're going to insert is actually the index, and that should be good. We can also insert the index, and well, we can insert whatever we want. Okay, but this doesn't have to be anything into stack, but we can insert anything we want, and we can insert the value if we want to. So we'll just insert the index because we can get the value later. All right, so let's implement it. So create a stack. Right. One thing I want to do is move all of this to the top. Okay, time for the implementation. So create a stack, answer. This answer is going to be, of course, -1 times the length of nums. And we're going to create, there we go, done. So now we create a double for loop, for in range 2. So that'll be 2 loops. And what we're doing for each loop, we're going to go through all the nums in the stack for I in range, lang nums. Of course, our num is equal to nums at I. That makes it easier for us to think about, less to worry. What else are we doing? So let's see, while loop. Okay, so while stack and stack top is less than or less than num. It has to be less than. It has to be a greater number. And that means what we're going to do here is pop this item. So stack dot pop. What we're popping is, depending on what we want, let's just pop the index. Index equals stack dot pop. And what's that, our answers? Or answers. At this particular index that we popped from is going to be equal to this num that we created recently. Okay, with that, we have set up all the things, we also, last thing we need to do is in stack.append this particular index. Not this index, but this I. And with that, we are good to go. That's exactly what we have set out to do. And we have done that. And it should work out pretty fine. So let's run the code. Okay, so it is wrong. So we have 2, -1, and -1. And we're missing the 2. Why is that? Let's take a look. So we do this loop twice. It should be inside our answers. So why isn't it? Let's see. So, okay. So let's say we have our, let's do a review then. Let's say we have this particular input. And our I is here. And this is our stack. So we first insert the first I, which is 0. Okay. Into the stack, because there's nothing in the stack right now. Then we insert number 1 into the stack, because this, if we look at, oh yes, stack number 1, that's an index, that's why. What we're looking for is num at stack. There we go. So slightly confusing there, but we managed to find the issue, and let's run the code. Okay, perfect. With that, we have solved the problem, but however, the problem that we have encountered is that this is hard to think about. The stack and getting the index, and it causes like a coding issue, right? So what we can do is to evaluate this problem first, and we'll come back and make this more readable. So as promised, let's take a look at the evaluation. And it's O of n as expected, because we go through 2 loops of the nums. Because 2 loops of nums. And O of n for space, because answers is length of nums. So let's make this better somehow. So instead of storing just like index into, we're going to store both the index and the num. And this way, we will be able to get the right item without too much trouble, without calling nums. So we can go to -1 and look at number 1. So it's too bad that we are unable to set this to be like, okay, this is going to be our num, but this is as I guess codified that we can possibly get to make this easier for us to think about what's going on. Also, when we insert into a stack, we have the index and we have the num now. So, so we're getting both. One thing we could do is do enumerate, because we're going to be using both anyways. So I think it's a good idea just to do that. So I and num in enumerate at nums. How's that? With that, we can lose this line of code and make this answer more clean. So let's check it out. Let's run it. It should work perfectly fine because it's the same exact code, right? Oh, right. This append. We're appending not 2 items. We're appending a tuple. So little coding error there. So answer index is equal to num. So right, this is when we pop. That means we have to pop both the value and the num. Just pop the. Yeah, pop both. What are we gonna do with this num? Just say previous num. Yeah, we're not gonna use that. So run the code. All right, great. This might be slower. I don't know. It might be faster, but we'll see. Oh, look, it's faster. Great. So with that, we have solved the problem. We made it a little bit neater to read, a little bit better to read. Yeah, that's all. If you have any questions, please comment below. If you enjoyed this video, like and subscribe. And remember, if you want to figure this out for yourself, the best way is to go for next greater element number 1 to see what's going on. It'll be a little bit more clear because the problem is a little bit easier. And so it's like recursively making things easier for yourself. Like, okay, let's answer the simplest question possible that is of the same topic. Then let's answer something a little bit more difficult. And then let's take that and we're going to apply it to the next video or next problem, which is going to be even more difficult. But look forward to that. And I'll see you in the next one. Bye.